Okay. Can we get everyone inside? Everyone staring at the top 3 finalist cars, please come on in. We're going to get this rolling. We've got design judges that have to head to the airport. If we don't do this now, it's not going to happen. I'm Steve Fox, Chief Design Judge for Formula SAE EV. This is Dr. Dave Retzis, Co-Chief Design Judge for Formula SAE EV. This is the official 2023 finalist design review. Take it away, Dave.
Okay, you may notice there's 3 cars parked out here on the east side. These are the ones that the design engineers had determined were the most worthy, if you will, in terms of design excellence. Doesn't always mean that the actual hardware was the very best, but the knowledge demonstrated by the team was considered to be the finest 3 that we saw this week. Before we delve into that, though, we start off with supposedly 75 cars. 67 were going to be here as of Monday, and we had 59 of you actually come through design, which was a little lower than we would hope, but it was a little bit higher than we expected. So hats off to all you teams, no matter what your score was, for actually making it through for the last year just to get here. So that's a big accomplishment, and you all deserve a lot of credit for that, obviously. What we're going to do today, or this evening for a little bit, is Steve and I are going to cover some fundamentals with regard to how we should be developing a vehicle and things to look out for. We'll also have Ethan Perrin from Tesla and Greg Massey from Lucid is going to cover a few things with regard to high voltage and low voltage battery management and tractive forcing and torque vectoring and fun stuff like that. But here again, this is a review. This is not a whole lecture, obviously. So to start off here right away, one of the first things we worry about is in a vehicle is compliance. Now, when we say compliance, one of the first things we see are physical compliance on the car. In the suspension, in the seat, in the steering, in the pedals. Okay, we'll talk about safety in a second. Steve, you want to mention a few things about suspension compliance?
We see suspension compliance all the time in a lot of the poorer cars, and honestly, if you've got suspension compliance, your car's not going to react properly. You're never going to be able to tune it properly. Any adjustments that you make, the driver's going to come back in and say, did you make an adjustment? Well, the answer is yes, they did, but the suspension compliance took it all up, so it's really hard to tell if the car is actually reacting better or not reacting better. Seats. There's no place for padding in race car seats. We still get some teams that show up with padded seats. The best seats that I've ever seen, or the best seat that I've ever seen, was actually done by Cornell a few years ago. They took molds of their 3 or 4 drivers and made a composite seat that fit them like a glove. It was extremely contoured exactly to the drivers. They could lay in it and fall asleep as if they were in a recliner. That's how comfortable it was, even though it had 0 padding whatsoever. If you've got padding or compliance in the seat, or the seat mounting system is not correct, the inputs that you're putting into the controls of the car could be misstrued and you don't have complete, entire control of the car. It's a pretty simple thing. Compliance is your enemy. Stay away from it. Pedals are the same thing. We see dreadful pedal boxes sometimes. You can stand on the brake pedal and watch the entire brake pedal box moving back and forth. That's not conducive to good lap times because the driver often loses control of exactly where the pedal is. You lose track of where it's at, and it makes it difficult to get the car to make a fast lap. Safety third. Oh, sorry. Safety is first. Everything that you do should have an overall safety aspect to it, so never sacrifice safety. One of the things that we always talk about in my lectures when I go out to the schools is when you do this as a student, it's pretty low risk for the most part. But when you graduate and you've got lives on the line, you don't want to be the one that made the mistake on that part that caused the car to crash, that caused the driver to be injured or die, or cause pedestrians or bystander to be injured or killed. So safety is always first. Dave?
Yeah, as you saw with safety, obviously we had an incident today. We've been very lucky not to have anything like that. It's going to be up to you in your future endeavors with these projects to make sure that type of thing doesn't happen again, okay? Learn from it, okay? Like I said, the last 10, 11 years, we've actually been quite fortunate not to have anything like that. We don't want to see it again, and we know some of the circumstances why it could happen, but it's up to you to always do that. We always say when we give lectures, who's the safety officer on the team? It should be everybody, not just one person. Okay, there's not one person in charge of safety on your team. You're all responsible for it. So if you ever see something that's not right, and even if it's another member in the paddock, or when you're out testing your own vehicle or you're in the lab, you see something wrong, call them out, okay? I mean, losing a limb is no good thing, or losing your life is obviously worse, but in most cases. But be sure to be ahead of the game there. Be proactive. All right, the other thing about compliance, which is another kind of a nasty one that we don't like too much, that's administrative compliance. And this year, believe it or not, it was a little bit better than last year. But we've had issues with lots and lots of your documents showing up late, and the documents don't resemble what the original template is and what the constraints were in terms of, what the size of the design briefings were to be. So when we say template compliance, we're talking about your design briefing, for instance, okay? We saw some up over 84, 85, 90 pages. We said no more than 59 pages. And I hate to do it. We talk about it. Should we do it? Should we not? We want to be nice. But we say 59. We don't mean 61, 62, or 80, or 105, okay? So please keep that in mind. This year we had 33 penalties. Last year was 42, so I guess we're improving. I'd like to see that to 0, okay? And the other reason for it is when we're looking and reviewing your documents, it's important that the design spec sheets are appropriate because we have ways of bringing that into our own master, and if it doesn't fit right, then your car doesn't get represented right when reviewing your car in the context of the totality. So there's a reason we have it, not just because we're trying to dot every I and cross every T. In a fair number of cases, it's pretty clear when the students have not read the rule book. Okay, that's a straightforward deal. Read the rule book. Okay, you can like some of the rules, you can not like some of the rules, but they are the rules that we are playing by in any given year. And in racing, that's part of the deal. You got to follow what's there. You can certainly put in proposals to have things changed if you don't like something, but make sure you're there following it.
I like to tell students that if you're designing any particular part on the car, you have to understand the rule that that part has to comply with. If you don't understand the rule, you shouldn't be designing or implementing the part in any way, shape, or form. Rules first.
Also, if you don't understand what the rule limits are, you don't know how to be super clever to get ultra close to that rule or even bypass it slightly, okay? We have our score sheet, we have a deal. If you came up with something really creative, it might cause them to change the rules because they didn't think of that, okay? So that's kind of your job, is always push to the edge there, not to exceed the rule, but you find where a little bit of a loophole here or there is, and maybe it'll cause us to have to change it, okay? That shows that you're thinking. That's what this is all about, is your thinking process. It's not just whether you can do the math. It's can you read it through and figure out how your work's going to fit in the overall equation.
We see structural issues all the time. The biggest number one offending item that we always see is rod ends and bending. If any of you don't know what rod ends and bending, come and see me afterwards. I'll draw you a picture. But honestly, you shouldn't be a Formula SAE student, especially if you're in your second, third, or fourth year, if you don't understand the basics of rod ends and bending. Unfortunately, one of the design finalists that were in finals judging last night, Friday night, had rod ends and bending. They had an awful lot of other good stuff on the car. We elected to take them in anyway, but generally speaking, rod ends and bending is a huge no-no. We really frown on it.
And that becomes a safety issue at times.
It certainly is a safety issue. We've seen plenty of rod ends break when they're in bending, and that means control arm or wheel goes that way, car goes that way, and it results in unhappy students. It's that simple. Nodal analysis.
May I add one other quick thing?
Go for it.
Many of the things you'll see on the various websites and Formula SAE forums about this is the hot setup, this is what we did, might be for an IC car. If you start working with four-wheel drive, and we had quite a few cars this year that had four-wheel drive, and the cars you see in the demonstration here have four-wheel drive on all three of those samples, you're going to put some forces into your suspension, especially your front suspension, that it never saw before. You're going to be braking, you're going to do a variety of things in cornering that were not typically done if there wasn't a motor on that wheel. So it's not just the fact that the weight of the motor is there, or the mass of the motor is there, causing differences in frequencies and so forth. There is a whole issue there in terms of where the direction of forces that you would not normally have with just a traditional braking system. Okay? So keep that in mind. You do have a different vehicle than what a traditional IC car is, and you shouldn't just copy it because that's what they did. That goes for the nodal analysis as well. Where are you putting your different beams? Okay, if you're going to have a pickup for suspension or other structural area, you want to put it where the beams are actually intercepting each other in the triangulated region, not in the middle of the triangle, at the vertices. Okay, Steve, anything else on nodal you want to get into here?
Nodal analysis it's real simple. If you're doing a tube frame chassis, you're looking for overlapping tetrahedrons. Wherever they intersect, where there's a node, that's where your suspension pickup point should be. You shouldn't have a suspension pickup point in the middle of a tube. It's got too much compliance. Compliance is your enemy. We saw a car here this weekend that had 7 and 8 tubes intersecting at one node. It's a bit extreme. I think the design could have been done better, and we had a conversation with that particular team. Use your heads, use your FEA, do the best you can, and keep it as simple as you can. That's how you end up with lighter weight structures that are strong enough for the loads that you're going to play with. Tub versus tube. We get this question all the time. Should I do a tub for my car, or should I do a tube frame for my car? There's no correct answer. I'm not going to say this is best or that's best. What I'm going to say is, what are the capabilities of your team? Does your team have a strong metal shop that deals well with metalworking machines and cutting miters and tubes and fish mouths and tubes? If so, you might want to consider a tube frame. If your school happens to be really strong in composites, then you might go the opposite direction and build yourself a composite frame. There's no good answer. We'll take either one, but when you show up at the competition with whatever it is that you make, be prepared to defend it. You have to be able to explain to us how you made it, why you made it the way that you did, why it's got the design it does, and why it carries the loads that you think it's going to be subjected to. Very simple. Sims are not validation. I like this one a lot. We frequently get students that show us the FEA analysis for their particular structure, call it a control arm or a frame or a whatever. And we will then frequently ask them, well, did you test the part that you made for accuracy against your simulated part or your FEA analyzed part? Frequently we'll get an answer that says, no, the results didn't match. And we'll ask them why, and they'll usually always say, not always, but in too many times, they'll say, well, there's something wrong with the test. Trust me, there's nothing wrong with the test. What's wrong is that you didn't constrain your model correctly. It gave you inaccurate results, which skewed the results that you got from your test. If you test the part to destruction, it should match your sim part within 2% or so. If it's not within 2%, reanalyze what you're doing, figure out how to constrain the model correctly, and ask questions and figure it out. 2% is a pretty good number to stick with.
Notice that doesn't mean fudge the model until it fits the data, okay? It means understanding the principles properly when you're doing the simulation. We see this so often where teams have it and says, well, it's all going to be proportionate anyway, it'll be okay. Well, the more advanced you get with the simulations, the more issues you have of approximations. If you've ever studied chaos theory, there's situations you can be out of link by just a little bit, and those variations can grow, particularly when we start having some vibration issues. So don't just sugarcoat it or just say that's close enough. You should always say, hey, do I understand the underlying principle and why my simulation wasn't quite right? You can accept that it's not quite right, but you got to understand why it's not quite right, if that makes sense. Related to that somewhat is when you do a lot of work on simulation and for tubes as well as composites, you can often find you can have a stronger chassis, even less tubes or even less layup of the carbon. Just piling it on and putting more tubes isn't the answer. Strategically in the right locations is what will give you often a stronger chassis and suspension members and so forth in the right force directions, load pass, done with simulation typically, that could actually be a lot lighter. It could be stronger and lighter. Why do we care about weight? Weight does matter. F equals ma, right? Well, the heavier your car is, the stronger and bigger you got to make everything else on the car. Your brakes have got to be a little stronger. You're going to use a little more in the regen if you're going to be primary regen braking. You may have to go to bigger tires if the car gets bigger and heavier. It's not just the acceleration in a straight line that's harmed by the weight. Your braking is affected, your cornering is affected, and everything else just gets big. In some cases, for production vehicles, gets expensive at times too. This year, I would say the EV cars have come down quite a bit. We're in the order of about 10%, 8% lighter than we saw in previous years, going back to last year in particular, with one exception in particular. I want to show you an idea of what the weight distribution looked like for this year. And this is based on the first 50-odd cars that went through design, or the scales on Wednesday. Okay? Some are down in the 170, 180 kilogram region. Okay, we're over on the left, over on Steve's side over here, okay? We're not looking over here. That just don't really dry either. Over there, where it's 170 or so. We've got a collection of cars there. The first 5 to 10 cars are right at about 200 kilograms, a little lighter, okay? Years ago, that was somewhat unheard of to see in an internal, it was decent in an internal combustion engine, but to see for EV was kind of unheard of. Most of those cars are actually four-wheel drive vehicles, so they're carrying 4 motors around as well and the wiring to go with it, okay? So when someone says, well, my car's heavy because I've got 4 motors on it, well, how do these teams get their car lighter with 4 motors on it and run and finish endurance, okay? So keep that in mind. Just because you got more functionality does not mean it's got to be heavy. Yes, things got a little heavier. If you're out here where the 40th or 45th car was, we're pushing 250 kilograms. That's getting pretty up there at that point, okay? That's what we used to see with EV cars back in the mid-teens, 2015, 16 cars. Since then, they keep getting lighter and lighter, okay? Yes, we did have an exception, and that team knows all about who they are, and they'll be working at it, and I'm sure they won't be there next year at that elevated weight.
You are all to be congratulated because the cars are lighter than we've seen in any year previous. So kudos to you all. You're doing your diligence and you're doing your homework and you're starting to show up with improved products that are lighter. Thank you very much for that. I look forward to seeing next year's efforts.
Okay, I'll cover a little bit of this plumbing and wiring. I like to use something like it says in the bottom here, make these perfectly invisible. We don't want to see wires all over the place strung out. They may be wrapped or they may be loomed. They should be almost non-existent from an outsider looking at the vehicle or from a driver getting in and out of the vehicle. We see in all levels of racing more damage is done to brake lines and a variety of electrical wires that are done as the driver's getting in and out of the car or as the mechanic is working on the car, okay? On the track, it might be okay, but if you can't build in such a way when you're servicing that it doesn't get damaged, and guess what happens? When it gets damaged, then you got a field fix. Those field fixes never seem to get fixed back to where they were originally. It's always a patchwork or a quilt work, okay? So if you design it well to begin with, keep the wires out of the way. There are some interesting books that judges have written. I'm sure many of you know the Learn and Compete books. There's a whole article I'd written in there about how to do wiring and getting your wire sizes correct and how to radius the routing of the wires so it's safe and so forth. Take a look at that kind of stuff because even with some of the better level teams we saw this week, I still see some pretty heinous wiring areas, okay? We can go on and on about that, but that becomes an issue. Coolant lines, controlled cabling, any of the harnessing, brake lines obviously is an issue as well. We don't want to see that stuff right next to something that's going to get very, very hot, for instance, okay? We may not have an internal combustion engine here, but we've got some issues where we're seeing motors can go very hot, and battery packs. Oh, by the way, we're not supposed to call them accumulators anymore. They're now battery packs. That's the new code word for the year. So control cabling is often very delicate. You make sure you don't have that right next to something that's quite hot or is going to get abraded. We've seen some cases wires down, this far away from the ground. If you got 2 inches of compliance, you're touching the ground with the wire. How long is that going to last? Okay, keep that stuff in mind. Make your wires, we show up and says, geez, they haven't done a harness yet, have they? Okay, and then you'll see, oh yes, they actually did. It was done quite well, but it was hidden and it was not going to get damaged. Okay, we're going to bring Ethan up here from Tesla. He's one of our esteemed judges. Actually, it's interesting. Ethan was an assistant for us last year, and he's gone on to be one of our senior judges and doing a great job. So he's going to talk a little bit about mechanical design integration, component selection, and power integration, particularly for the HV areas.
Hello guys, you guys all had a large number of very impressive battery packs this year. We've been seeing the improvement year over year being quite rapid. This is great to see. Most of the topics I want to cover are a lot of feedback that I gave to a lot of teams. There's a lot of first year teams here. So hopefully there's some guidelines you guys can take forward, and when we see your teams next year, we'll see a lot of improvement. So starting with mechanical design. Go next slide. Key points here, a lot of teams, they focus very heavily on packaging their cells very well. We saw a lot of very compact modules in a lot of cases. And then we look at the rest of the enclosure, and we see all the other components inside the battery pack didn't really have a defined home, and there clearly wasn't as much attention to detail in getting those components as densely packaged as they could be. There's a whole lot more that goes into a good electric powertrain system that is not just the battery cells themselves, even though that is usually the starting point for most pack designs. Other points, make sure you utilize the battery enclosure. It's not just a box by itself, but it also is integrated very closely with the rest of the vehicle. It affects the dynamics of the vehicle as being the single heaviest component, and it has a lot of other requirements about ingress protection, airflow, different cooling system requirements as well. And you have an entire chassis around that battery pack and a lot of other aero components that you can utilize to better integrate the systems and make it so that the total overall vehicle is a lot lighter as a consequence. Batteries are also typically the most complex single assembly. They have the highest part count of any part that you will take in and out of your car. And so as a result, it's pretty much universally the hardest part for new teams especially to get reliable and to have confidence that they can rely on it in competition. Keeping that in mind, you want to design your entire battery pack, all the systems, mechanical and electrical, that can be easily serviced and maintained, oftentimes at the expense of possibly some density or some weight. It doesn't matter how densely you pack things together if you keeps breaking and you can't figure out why, you haven't passed tech inspection yet, or you're about to go to endurance and you keep getting faults. In which case, that battery pack might be super light, but if it was 5 pounds heavier and easier to work on, it's a hell of a lot faster as well. Something else to consider is all of our professional racing circuits, when they need to swap out parts or perform repairs, they don't try to do it in the one battery pack that they have. They'll have spares on hand and swap them out. A lot of teams, they quickly learn about the value of modularity. You guys already have segments that your battery cells themselves are divided up into different units of energy. You can take the same approach for all other components of your battery system. Cooling modules, your contactors, your fuses, those can all be modularized as well. So if you have some fault, you don't have to solve it right away. You can swap in a spare that is known good and continue with competition. And that will really help speed things up when you guys are pressed for time. And the last thing here, safety goes far beyond the rule book. Within Formula SAE and Formula Student, the rules are constructed to help teams have an introduction to battery design and electrical design in these high power systems that's going to keep things safe while you guys are working on them. But once you go beyond and you start to work in the industry or other applications, there's rule book isn't going to be there. There's laws out there, but they do not keep up with technology that's available. Number one users of this battery pack are you guys as the students. You bring them to competition for only a few days in which they get scrutinized, but the entire rest of the year, they're sitting in your lab, in your shop, and you guys are the ones handling it. So it's in everyone's interest to make sure that they're very safe. With that in mind, design is going to be your primary defense against anything happening. We try to build up a culture of safety and how to handle these high-power systems. But ultimately, the more you can design in upfront as the person who knows the system best, the safer the overall practice is going to be and lower the risk down the road of anything unfortunate happening. For BMS integration, a lot of teams, as they're starting out, may not have the electrical support to do a fully custom integration, but most of these guidelines still apply. The battery management system is not just for safety and rules compliance. It's probably the single biggest tool you have to understanding what's going on inside the battery pack while it's driving down the course. It collects temperature data, it collects voltage data, and that's the most important data you have to assess how well your electric powertrain is doing from a thermal and from an electrical perspective. So with that in mind, you want to remember all of its capabilities, understand what it has to offer, and make sure that you're utilizing it as well as possible when you're placing your thermistors that are technically rules compliant but may not be actually measuring the cell temperatures that are useful to you. As repeated above, cable management and accessibility, a lot of these off-the-shelf systems that you guys are using when you're starting out, you're going to have to run a lot of wires for voltage sense, you're going to have to run a lot of wires for thermistors. It's easy to forget those take up a lot of space, and if you need to debug why one voltage channel is not reading properly, being able to find that wire and know that it has a secure location is going to save you a ton of time, and you want to be spending as little time as possible when you're debugging a high voltage system that's potentially very dangerous. With that, another part of that is if you're going to be pulling things in and out of your battery pack, you want to be able to design it so that you can assemble and reassemble the system in a safe manner and protect all of these electronics from damage. The modules themselves, there's a lot of fairly straightforward ways to keep the high voltage isolation within the cell arrays fairly well separated. But when all those voltage sense lines come back to your battery management system on your slave boards or on your centralized unit, those high voltages get a lot closer together, and faults in that wiring or in those connections can snowball into other problems later on. So you want to be thinking about safety, not just where it's rules required, but everywhere in your high voltage system. Move on to the next slide for conductors. With regards to other component selection, not just your cells and not just your cooling system, you should know your materials inside and out. So we're talking about copper, aluminum, nickel, plastics, other composites. You want to know all about the different properties of the materials, what are their pros and cons, why you want to use them in certain cases, what benefits they have to offer. In many cases, challenge the manufacturing specs. A lot of these specs are given under certain assumptions about boundary conditions or use cases. Almost none of them apply directly to motorsports. You should know what the global optimum of your component is. You should know how to optimize it fully. Don't just go by the rule of thumb handbooks or what the manufacturers say is okay. A lot of times those specs can be pushed even further, and you can choose things that are much more aggressive to optimize your design, save size, and save weight. And a huge component of that is physical testing. Even though your handbook may say you need to use a 4-gauge or a 2-gauge wire to handle the current that's required, those are based on some thermal assumptions. So why not run a smaller wire and let it get hotter if the insulation is rated to like 180 degrees Celsius? And you should know, is that a safe trade-off to make, and what are the other boundary conditions in the problem? If you have the test data to back it up, then you know the full system fully, and you know how to optimize it fully, and you know where the limits are. Again, mechanical packaging and service. When you're talking about outside the cells, you're going to have 2 contactors, you're going to have a fuse, you're going to have an energy meter somewhere in the system, and you're going to have to eventually route those out to a connector. If you can't physically assemble this system and easily access, if you blow your fuse, or you need to be able to install the energy meter, if you can't access through the packaging that you've designed all of those components safely and easily, it's going to cost you a lot of time, and it's going to cost you a lot of frustration. And that's not something you want to be dealing with around a high power system. On cell selection. Cells are extremely complicated. They can often seem simple at first, but companies as big as Tesla and many other automakers, it's a continuous process discovering about all the new physics involved. Luckily for Formula Student and Formula SAE, those are not typically problems that you have to solve, but you do need to understand all the basic fundamental relationships about impedance of the cells, how they're affected by temperature, how cycle life comes into play, and understand the differences between the different form factors, pouch cells versus cylindrical, what those have to trade off to each other, and how you're going to make a better selection. Ultimately, if you're constrained by the amount of money you guys have available or the cells that some prior year was purchased, we understand those limitations, but we also want to see that you guys understand that those constraints may not always be present, and when you have to make a choice about what are we going to do next year, what are we going to do the year after, and what should we be pushing towards, that you understand all those trade-offs. The cell selection and understanding what's happening is pretty much the foundation of the entire thermal system of your powertrain and how you're going to be able to size this system to work with the rest of your vehicle. So we really drill down on understanding all of these fundamental concepts, and then we also want to see that you understand the physical products you have in front of you with testing. Even though you may have access to test consortium data that's coming around, much like we have tire test data, you still need to test the actual cells that you get on your hands to confirm all these specifications. Again, just like cables and conductors, they're not going to be the same as the data sheets reported under some other conditions. Motorsports is very unique, and you want to test them as close to the application as possible. Go to the next slide on pack sizing and cooling. So these 2 components are typically the hardest for students to get right. There's many answers to how to size your battery pack and how to size your cooling system if you need one at all. Generally speaking, the requirements for your battery pack, these should come from, could be a small team or it could be another entirely different group on your team. But there should be some level of vehicle simulation going on based on starting from the tires all the way through the physical dynamics of your car, and that can tell you about how much torque you need to be putting down, how much current you need to draw to provide your motor to deliver those torques. And ultimately, those models should work bidirectionally with how you're going to size your battery pack. If you don't have a sophisticated model, there are many other ways to augment that resource, and in either case, you should have track data of some sort. If you don't have your own track data, there's data available from the competition about how things have gone, and you'll be able to make some rough estimations about how vehicles are going to perform around the track. Asking other teams is a great resource. Everyone I've ever met in Formula SAE is pretty collaborative. So from that, you're going to get your requirements for how your powertrain and your battery pack has to perform. But important to remember that those aren't the only requirements, not only when you're driving on the track, but you also need to remember that the cells that you're going to use are going to vary in quality. They may not going to have all the same impedance, and depending on your supplier, you may have issues with some cells not meeting the specs that they claimed. And that's where testing and understanding the possible variation could possibly mean you need to add some conservative safety factor to your capacity. Similarly, track temperature varies wildly, and it also affects how the batteries are going to perform, so you might want to understand how that impacts your pack sizing. And if you're going to drive a pack for more than 1 year, as some teams often do, if you drive for 1 year, maybe that car started driving in the parking lot and it only has like 2 cycles on it by the time you get to competition. But if you go through a year of running after you come back from competition, and then that pack is going to be used again at the next competition, it's now 50 cycles old, and that's going to affect its available capacity as well and its performance. And so those are all questions that we need to answer often in industry, and all things that we're going to ask you about as well, so that you understand all the relationships involved in sizing a battery pack. And lastly, something that I encourage a lot of teams to investigate is the powertrain heat output for both the battery pack, the motors, the inverters, is extremely sensitive to the amount of power drawn by the drivetrain and how much power the drivers want to assert out of your control system. They're very sensitive to the peak power, but lap times often are not. So if you're able to develop a pack model or even test data that shows that clipping the power by a few kilowatts may not change more than a few hundred milliseconds off your lap time, it may have huge consequences for the size of your cooling system and may even enable you to eliminate it entirely. So those are sensitivities that you guys should pay attention to and look at when you're sizing your battery packs. Leading into that, the cooling system. This is by far the hardest part for people to get right. In fact, it's the subject of entire careers of work to understand how powertrains should be cooled and how to size them properly. It's also an easiest place where people kind of start in a good spot, but they quickly go off the path and go down rabbit holes that look correct, but because they don't have any validation to back it up, it's hard to understand if the results that you're seeing are good or not. One of the core reasons for this is if you have mechanical engineers and electrical engineers, they often have a fairly decent intuition for how loads transfer if tubes or other components are well sized or not. Having thermal intuition for heat transfer is pretty much impossible. Once you start getting into the weeds of these very niche applications, it's very hard to intuit what's going on and see if the answers that you are providing out of your analyses are correct or not. And for that reason, the biggest advice I can give you is to ground all of your analysis in physical testing as soon as possible. You want to make sure that if you're going to rely on a model of any kind, that you're able to quickly assess if that model is accurate or not. Otherwise, it can lead you very far astray. And also important is that a lot of you will take thermofluids classes in school, and they're going to teach you a lot of equations, and they're very useful only in certain cases. It's very rare in practicality that those boundary conditions are ever going to manifest, and so you need to pay lots of attention to how you're setting up any of your simulations and any of your hand calculations. That physical testing data is always going to be real, and it's always going to be repeatable. Last thing I'd say is know your system sensitivities. That's what I mentioned last about pack sizing. Adding more cooling potential to your battery pack is not the only solution. You can also decrease the heat input to the system. It's also possible you can decrease starting temperatures and by other means. Perhaps you need to add more capacity so that there's more thermal mass available. So there's more different solutions than just adding more fans or going to water cooling. And those are all things that you should know about and how to trade between those different options. With that, I can welcome Greg up.
Thank you. Thank you, Nathan.
That was Tesla. Can I tell him about the October 1st thing, Ethan? Can I tell him about the October 1st? Tesla will host a seminar again this year on October 1st at their facility. They're also giving away free. You can get free batteries from Tesla. Ethan is the guy you're going to talk to. He's a wealth of information. I can remember when he was a design intern, and he was really quiet. Now, can't shut him up. He knows an awful lot about his subject. Greg, take it away.
Hi, my name is Greg Massey. I'm a chassis controls engineer at Lucid Motors. I work on traction control, stability control, torque vectoring. And today I'm going to talk to you about regen and friction brake interactions. For the cars that have regen, that becomes a really important topic. How to do good software development and validation in order to make sure that you have software that's going to support the team's goals and make sure that it's going to be running by the time that the car is running, and you're not going to have to spend a bunch of time troubleshooting issues, as well as torque vectoring. Okay, so you're adding this new type of braking to a car, and that's going to have a big impact on the dynamic performance of the brakes. Especially on a rear-wheel drive car, if you're adding regen, that's only on one axle, and it's going to have a huge impact on your brake bias. Obviously, the brakes still need to be sized to stop the vehicle without regen. That's critical for the brake testing where you're not allowed to use it, but also, it's an important safety issue in case you in case your powertrain fails, you need to make sure that you can still bring the car to a safe stop. That said, if you're confident that you're going to have regen available for, say, an endurance, you may be able to reduce the thermal sizing of your brakes. You want to be able to make sure that you can stop a couple times, but if you're going to have regen and be able to recapture that energy, you may be able to give up a little bit on the thermals of the friction brakes and therefore save a lot of weight and add some performance. Another interesting topic is brake distribution. Like I said, on a rear-wheel drive car, all of the regen is going to be on the rear axle. That's going to have a big impact on the brake bias and how you size your foundation brakes to make sure that your bias is appropriate. If you've got an all-wheel drive car, it opens up a lot of opportunities in terms of now you have this electrical system on, helping the brakes. What do you want to do in terms of brake bias versus speed? If you've got an aero car with either a rear-wheel drive or an all-wheel drive car, you can now vary your brake bias depending on the speed to match the load transfer that you're going to have at high speeds with more downforce and more load transfer, or at low speeds with less downforce. Another really interesting topic that I've seen a lot of interesting solutions to this week is the trade-off between doing your regen on your accelerator pedal or your braking pedal. There's no right answer. In industry, we're seeing a lot of people do either or. Some benefits that you might find is that if it's on the accelerator pedal, you're more likely to make full use of the regen available. As soon as you lift off, you're going to be regenning. You don't have any blending between brakes and regen that you have to deal with where you're going to be giving up electrical recovery because you're pressing the brake pedal. But it may be a little harder to drive and get used to. The drivers only have a couple days with these cars a lot of the times before competition, and so making something that's familiar can be helpful as well by using the brake pedal. Another important thing is considering what happens with regen in a turn. If the driver lifts off in the middle of the turn, with a rear-wheel drive car, that can cause a stability issue. So it's important to make sure that you consider potentially reducing the amount of regen that you do in a turn. And that also matters for all-wheel drive cars. You don't have the stability issue necessarily, but if you're doing a lot of regen in the middle of a turn, you're going to reduce the lateral capacity of the tires and hurt the performance that way. Go ahead. Next up is software development and validation. I will say the level of software that I saw this year was really impressive. It's improved a lot over the last couple of years. As with any system on the car, any software should be able to be tied back to the team goals. What are the requirements, either rules or something, in terms of the powertrain needs a certain input to close contactors or whatever else. You should always be able to tie back why you're doing the software that you're doing to certain team level goals or rules or requirements. Another thing that I saw that I really liked, several teams using very modular code that could be really easily implemented onto a bunch of different ECUs on the car. Teams using the same microcontroller and the same architecture on all the different ECUs of the car, and reusing libraries for different things like CAN interfaces and stuff like that to make it so that you have tested, understood code that you can reuse and re-benefit from across the entire system. Another thing is testing. Testing is very important, just like a mechanical team. It's really important that you test and understand all the intricacies of your system and that you don't have any cases that you haven't seen before. This testing can be done on a bunch of different levels. Whether it's a unit test where you can test a specific function and make sure it does the exact thing that you want it to do, or an ECU level test where you have a board on a test bench and you're able to spoof CAN messages, send analog voltages, maybe compare it to other ECUs that you can buy and confirm that the input is reading correctly, as well as system level testing where you take all the different ECUs on your car, connect them with the wiring harness that you're planning to put into the car even, and be able to check the communications of each of the ECUs, making sure that all the different control systems are able to work together. If it's a control system that spawns multiple different ECUs, and be able to start to test things like fault logic, where you fail a sensor on one ECU and you confirm that the controls correctly degrade on the other ECU. The more you can do before the mechanical team is done building the car, the more likely you are to be able to drop that electrical system into the car and be able to start running right away. And that's going to maximize your team's already small, but hopefully a little bit larger testing time. Another really important thing that I want to touch on is failure modes. There's a lot of teams that are running traction control, torque vectoring, increasingly complicated control systems. And one of the most common failures is a sensor breaks, and then that sensor reading 0 going into the control system completely causes the control system to go haywire. It's really important that any of the non-critical functions have the ability to be disabled or turned off by the driver, even if it's just a simple switch. That way, if there's anything weird happening and the torque production's not correct, you can turn off the traction controller or something like that. Also, there's potential to be able to automatically detect faults. A lot of automotive sensors will read from 0.5 to 4.5 volts, and that allows you to say, if this sensor's at 0 or this sensor's at 5 volts, something's wrong. It must be shorted or disconnected. You can also do things like monitoring the current that the sensor is consuming. And a lot of the times, if there's a short or something like that, you'll see a big increase in the current, things like that. And if you can detect those sensors faulting, then you can disable that system automatically and save the driver some hassle of, where did my torque go? What happened? Oh, let me try turning off traction control. Maybe it can just be done automatically. Next slide. So this is an example from finals of a team that had all of their different ECUs laid out on a board with a harness, and they were able to fully test their system and then basically drop it into the car and have everything work because it had all been tested, it had all been integrated, which is exactly what we want to see. We want to be able to, get the car running very quickly right after right after it's ready to run. That all the electronics are going to be there and good and ready to go. Okay, torque vectoring. A lot of people think that torque vectoring is this mythical thing that's going to fix all their problems, and you're not going to need a suspension team anymore. Really, torque vectoring is just another tuning knob, like it's an anti-roll bar, a spring, a damper, a wing. It's really just another tuning knob, and it's really important that the vehicle dynamics team as a whole, whether that's the software controls or the suspension team, are able to look at their system and say, okay, what is torque vectoring really good at? There are things that torque vectoring can do really, really well that you can't easily accomplish with a anti-roll bar or a spring, and there are things that just have to be done by the springs, the tires, the anti-roll bars, and that the torque vectoring cannot easily accomplish. So with that, FSAE cars have very limited testing time, and I see a lot of people trying to do very, very ambitious torque vectoring systems. In industry, we have a car for a year and a half, usually, to be able to develop the control systems, calibrate them, and make sure that they're going to work in all the different situations and environments and with different driving styles and all of that. Obviously, a Formula SAE car is not going to have a year and a half of driving time that we have. Given we have a lot more environments, we need to drive in snow and ice and gravel and rain and all that kind of stuff. But it is very important to keep your controls simple, keep them robust, and make sure that you can have them work and be easily calibratable in order to make sure that you can maximize the benefit that they're going to provide. A lot of people make these very complicated math models where really a simple interpolation table would do very well, and that also provides the benefit of being easily calibratable at the trackside. You don't have to rewrite a math equation. You can just plug in a couple different numbers into your table. Another thing with the generally pretty amateur drivers that we have at Formula, it's really important that you consider how to make the controls intuitive and easy to drive. Some tips for that, like I said, open loop, tables of lateral acceleration and speed versus a torque split. That's going to do the exact same thing every time. It's going to be really repeatable and really consistent and also easily calibratable. Whereas if you try to do a full closed loop yaw rate controller that's looking at yaw rate and calculating a target and then doing a feedback loop on that, it is going to take a lot more time to calibrate it to make sure it's going to be consistent, repeatable, and do the same thing each time and be intuitive. Like I said before, the failure modes are super, super important. Especially with torque vectoring, you're talking about now being able to basically turn the car a little bit. It's really important to make sure that you can fail any of the sensors that are going in. So if your IMU fails, you're able to turn that off. If it's automatic, even better. But make sure to consider what happens when things go wrong. If a wheel speed sensor fails, if an IMU fails, what is the system going to do?
Thank you, Greg. We're going to do something a little different here. Actually, we've done this before at Lincoln. We haven't done it here at MAS before. We're going to bring a couple students up from one of these three teams. Actually, we're going to bring a couple students from each of these three teams separately. And I think through a little Q&A with them, I think you guys might find some interesting insight into how they got to where they're at and how they're going to stay where they're at, okay? Once you're at the top, doing well, top three, you want to stay there. So they're going to have their elbows out, not letting you get up to the top of the hill. But they've been kind enough to come up and show us a few things that they're doing or tell us some of their tricks so that you can at least have hope to catch up to them. So let's start off with the group from Michigan, Ann Arbor. I think we're looking for Luca, Emerson, and Chloe. Are you around here? Thanks. What's that?
Doesn't matter where we sit.
No, we'll stand. You don't have to sit if you don't want. I kind of. Okay. All right. So we got a couple of things here. This team is one of our finalist teams for design, and no stranger to being near the top of the competition quite a bit for both internal combustion and EV over the years. What I want to ask you a little bit here, if we can, is you're going to be transitioning from your existing team leader to a new team leader. Tell us a little something how you're going to make your new team leader be as successful as you've been.
Yeah, so over the year, we focus a lot on knowledge transfer. Every system that we have and every lead is responsible for keeping up a living document. So that goes anywhere from chassis. What did we learn this year? What have we done? Before and after every test, we go through our plan and analyze the data coming in. We include any member that is involved. That way they can kind of get active feedback. And the living documents are really the main method of knowledge transfer within the team. So throughout the year, leads, directors, and people involved will get the information into the document. And at the end of the year, we'll review it. Whenever a new member comes in, they can get access to the document and start learning and getting involved as soon as possible.
Anything else you want to add? Greg, a question?
Yeah, so I've got a question from Ethan. He had to run to the airport, unfortunately. How did you set up your vehicle dynamics simulation to integrate the entire powertrain and assess the battery capacity and heating that it would undergo?
Yeah, so our simulation starts with basically a hot lap of the track from the previous year, and we're looking to basically size a system that's going to be able to deliver our maximum power at the end of endurance. And so we start with that requirement and take that current profile and adjust it for whatever architecture we're looking to run in the next year. And what we'll do is actually trickle that down to a cell level and start with our cell selection with cycling that current profile over the cell for an entire endurance while monitoring things like voltage and temperature. That way we can validate that the cell itself is actually going to be able to complete the endurance, but also we understand the cooling requirements associated with that particular cell.
Awesome, thank you. How did the addition of torque vectoring affect the design of the suspension and tuning of the suspension?
So we designed with torque vectoring in mind, but we wanted to make sure that the suspension on the hardware itself was solid enough and we could make all the changes needed without needing torque vectoring at the end of the day. So when we started testing, we focused first on getting suspension for every event where we wanted it to be, whatever setup was appropriate for each driver and what they liked, what they didn't, gathering feedback throughout. Slowly we introduced torque vectoring. In our steering wheel, we kind of have a couple buttons that the drivers itself can change. So we'll have several calibrations pulled into the car. And throughout the test, we'll ask drivers to change it and give us feedback. We'll compare it to the data and see if it matches what we expected and kind of keep those changes and keep those in check. MIS has a little bit of a different surface than what we were used to. So we try to also use a little bit of previous year's data to adapt our torque vectoring methods to it.
Okay, well, I can really see here what Michigan has done here is they're working so hard at working on making a vehicle that's stable no matter what you do, okay? As Greg mentioned a little something about FMEA, if something doesn't work right, your backup plan is working. So if you're not got the torque vectoring quite right, your basic suspension setup is right there. So that kind of thing is a mature approach towards developing the vehicle. It's a lot more than just optimizing and getting all these simulations quite right. So thank you so much. We're going to bring another team up here. Thank you.
Michigan, Ann Arbor.
Are the students from ETS here? Come on up. Let's see. We've got, I think, Simon, Samuel, Steve. Okay. At first, we were going to have 2 of them, and then there were going to be 3. Now we got 4. So how's that for a team? Okay, so we've got a couple questions for you. You've actually been a team. ETS, ever since I've been judging, both in EV as well as internal combustion over the years, it seems like ETS always seems to be near the top of the heap, okay? It's not the same students, and I've discovered it's not always the same advisor. It's the same school. What's your trick?
Hi, everyone. So basically, there's no magic trick, but we do have very, very high standards. We hold ourselves to very, very high standards, and this shows within the way we handle ourselves in competition, in events, within the school, within different methodologies through our documentation. And we also make sure to implement these standards and this mentality to new members. As soon as they get in, it's always hard work. It's always high effort. Excuse me. But we make sure that this mentality gets installed as soon as you start with the team, through team goals, through car goals that are installed at the beginning of the year, and then we roll forward with these goals and these objectives all the way throughout the year to make sure we stay performance through all these years.
I think what you didn't mention is your relations with alumni and with sponsors are such that they want to keep affiliating with you because you make them look good, right?
Yeah, so as late as yesterday, as late as this afternoon when we were running endurance, alumni were texting us, making sure that they were getting the links, getting updates of how we were doing. During designs, we make sure to do design reviews with alumni, with external relationship, external partners, strategic partners, professors, to make sure we get different sets of eyes, different people involved through our design to make sure we hold ourselves, like I said, to that high standards, to that high performance, to make sure we keep our design very good, our manufacturing on point, and then we go to testing and performing on the track.
Thank you. Greg? Steve?
Yeah, so a question from Ethan. How do you integrate your pack design into the aero, chassis, and vehicle dynamics requirements?
Yes, hi everybody. Well, the question is really how do you integrate anything or everything? First of all, you need to have a bunch of people communicate together. That's the hardest part of integration. When we integrate our pack in the car, it's interfacing with the chassis, the aero, the dynamics through the chassis, and the powertrain, obviously. So it's really getting those people to talk together and for them to follow the same goal. Like Simon said, we have team goals at the beginning of the season and car goals, and everybody needs to follow them. So when we were talking about pack design, it was really the team goals to lower the weight of the car, some more performance, and the integration was really scanning down the pack volume, and some aerodynamics teams just said, oh, we can do something in the back if you shorten the pack a little bit. So, it put an angle at the back of the chassis integrated diffuser. The powertrain team designing the battery pack was like, oh, okay, I can integrate my cells to the back of the firewall and angle them so we can bring the CG to the front. The dynamics team was super happy with that. So, and even the chassis, having the diffuser in the back, bring the bracket of the chassis closer to the edge of the monocoque, making that stiffer. So it's just having a lot of people talk together, and integration is much more about people than design sometimes.
Yeah, awesome. Thank you. And how do you manage your energy budget for endurance? How does regen affect this budget and all of that?
Hot potato here.
Yeah. Hi everyone. A lot closer to you. A lot closer. It's usually it's always about state of charge. It's always important to keep track of the state of charge during the endurance event, and to know that exactly how much energy is leaving the vehicle during a lap, and also how much energy is entering the vehicle through regenerative braking. And a way to do that, a fairly simple way of doing it, is just Coulomb counting. It's not the best solution, but it at least gives you an idea if you're not doing anything. And you can keep track. You can try to see how many laps you got left if you keep the same pace, and you can go slower or even go faster if you feel like you're going to finish with a lot of energy left.
So at ETS, at the beginning of the season, with our lap time simulation, we define like a pack capacity required to do a full endurance. We doesn't take into account the regen itself, so it's only friction braking. And then by testing and also with the state of charge, as Jean-Carlos said, we're working to increase the regen. So the regen is just like a performance budget for us. So the more regen we do, the faster we can run, the higher the power cap could be. So that's pretty much how we manage the.
Awesome, thank you.
Steve, got a question?
I don't have a question. I'm just in awe of this team. You guys consistently come back with a great car and a great performance every year. I hope you continue this process for many, many years to come. Thank you. ETS, everybody.
Yeah, they've been something. I mean, it's. I will say one thing. It's interesting. We hear as judges all this time from students and other uninformed sources. Oh, well, this team has so much money. That's why they do so well. And so I asked some team, well, what if I gave you $150,000? What would you do to make your car better? Nicer uniforms? Better hotel? What are you going to do to actually make yourself perform better? Often they don't know. ETS does not run with a crazy high budget. A lot of people think they do. They just work real hard at making sure it's the very best it can be. They have a professional attitude towards it. They're not running on empty, of course, but they work with their alumni to make sure all that is adequate to do what they're trying to get done. So, okay, the next one we'd like to get some students up here are from McGill. I think we have here Walker and Alex and Guillaume.
I got to start this off day with fashion points. I got to tell you, they're dressed well.
That's the car logo, by the way.
Yeah, that is the car logo that's imprinted onto their shirts.
All right, I'm going to start with team organization a little bit here. You kind of floored us a little bit when we were talking to you earlier. Tell me again, because I'm not sure I can count this high. How many members are on your team?
We got 346 people on our team.
Okay.
That's not pounds, that's kilograms. So we got to ask, how in the world do you manage that? You had mentioned your Agile system and so forth, but give us a little insight. I'll be honest, I was going to do a little project management thing here for you this evening, but we're going to be running against time with all the awards. I think what they're going to tell you is going to cover a lot of stuff that I was going to talk about anyway when you're dealing with this many people to productively help the team.
Yeah, 346 people is a lot of people. It makes a lot of headaches if you start doing things wrong. The moment you get a little bit disorganized, it really runs away from you. So like you mentioned, one of the things we implemented this year is a bit of a hybrid agile waterfall workflow. And basically what that does is it makes it really accountable for what every single person in our team is doing at any given time. So we have an organizational structure that starts at the top with our management. Then we have our project leads, and we have the general members. And the general members are what make up the bulk of this team, this gigantic team that works together to make that car. So the management are the people that really set out the timeline, the milestones, and the big high-level objectives that this car needs to hit. And the project leads are the people who are really responsible to make sure that each one of those milestones, each one of those goals is accomplished. And the general members, at the end of the day, they're the hands that get that work done. So every week, our management team and the project leads, we sit down and we have a meeting and we slide tasks into out of our backlog and figure out, all right, what do we need to work on in the next week? What is the high-level stuff we need to accomplish in the next 2 weeks? These project leads, they pick on the amount of tasks that they think they can accomplish, given the school week. Sometimes you have finals, sometimes you have midterms, sometimes you have nothing. So it can really adjust the amount of work you can take on at any given time. And then they go out into the shop, they go into the computer labs during the design season, and they get work sessions going. They bring in all these general members. They're teaching them hands-on what they need to be doing to make this car. It allows us to make way more changes in any year than would be possible if we only had 30, 40 hands working on it. And it also means that every year we have a fresh set of new leads that can come in from this general member pool.
Greg?
Yeah, so the question from Ethan is, how did you approach serviceability within your battery pack?
Well, the answer is pretty simple, LEDs. So basically we added a ton of LEDs everywhere on all our PCBs, on our dash. We even have on the back of the chassis a transparent rear closeout where you can basically at a glance just see what's the status of our electronics is. So how we approach serviceability is by essentially assessing the issue in about 10 seconds. So we make sure to work with mechanical people so that the electrical and the mechanical package would make sense and all the electronics would be accessible to make it easier to service.
And what tools did you use to ensure your software and electronics would be ready on time and work the first time that the car drove?
We built an MFE in wood. So we built a mock-up chassis, which is exactly at scale. We build it out of wood with openings, with the same configuration as the real chassis. So essentially what it allows us to do is to parallelize the electrical and mechanical work so that instead of having to wait for a monocoque to get done, we could immediately start installing harness, ACU, installing the motors onto a scale model of a real monocoque. That allowed us to essentially fully debug and test the real harness, the real software that would run on the car. And so at the beginning of March, when the monocoque got done, all we had to do was spend a week to basically take the harness and the electronics from the wood chassis and put it in the monocoque.
McGill University, thank you very much.
Well, I'll walk them through it. I'll walk them through it. Okay, so again, thanks guys for sharing, okay? After we're all done here, and after, we're going to roll right into the closing ceremonies here in a second, but get a chance to look at their vehicles. It's not just about the fit and finish, it's the thought that went into all the different subsystems that they've got here. So all these teams have done a fantastic job of getting their engineering done, not just the assembly of a racing car. Okay, big difference. Okay, we can jump ahead a little bit here. some of the stuff we've covered a little earlier. I was going to cover some stuff on communication, but I think what they just covered here with McGill, I think covers it in a nutshell pretty well. I just want to do something that's going to take literally about 30 seconds. If you jump ahead one more. Okay. One of the problems with a lot of design is getting your requirements laid out properly. And as you go through the process, you find your requirements keep changing. Okay? Being able to handle that is a huge, huge problem, but it's an even worse problem if you're not communicating with each other properly as a team. Many teams will have weekly cycles where they'll meet. In many cases, that is not a good idea. You need to be more often than that, because you could have done a week's worth, or in some cases 2 weeks worth of work on something. You find out the requirements have changed. Those 2 weeks may be a complete waste. You don't have a 2 or 3 year design cycle. You've got a 10-month or less, 8-month cycle here to work with. So nailing down the requirements before you start doing all the builds makes a lot of sense. The problem you run into is if you nail the requirements down and you can't keep them stable, then you're going to be further behind later on. So you may find that you have to have realistic requirements that you can attain, particularly if you're a younger team that doesn't have the legacy, doesn't have the knowledge on board. Learning how the whole process works is often more important than going for the pinnacle of the perfect performance of the vehicle. Okay? There's always a question of prototype build, early or late. If you're a younger team, you got to get that car built so that you have a month or two of testing. Most of the teams that we dealt with here that made finals had upwards of 250 to 300 kilometers of testing. And that wasn't just over a weekend. They had problems, and then maybe in a month's worth they got to test the vehicle. If you don't have the car ready, I'm sorry, this is not going to be a great test area when you got some fundamental design flaws that need to be addressed. So try to finish it fairly early, of course. Even if it means you got to cut off certain things that you wanted to do. That might have to be manana. You have to do it for next year instead. Okay. I'm going to just mention real quick iteration effects and number of nodes. If you hit the one more, please. Okay. If you've got these different functions you're going to do, it doesn't just you do the first one, the second one, the third one, the fourth one, and you're done. Okay. One more time. What you find is you do the first one, you get to the second one, your requirements change, now you got to go back and do the first one again. And you don't have just 4 functions. You may have 4,000 functions you're doing, okay? If each one of these gets delayed, you have this real problem of the whole process getting very, very long. In the automotive engineering world, actual vehicle development, total dwell time moving forward is still on the order of 4 to 6 months to develop a car, even though it could be 3 to 6 years to actually get the car to production. And that's largely because these kinds of loops that occur that slow you down because you got to redo it so much. Can we hit it one more time? 90 to 95% rework is normal in engineering. That means you did your car 20 times over in the time period. Okay? If you hadn't anticipated you're going to have that problem, what do you think your car is going to look like when it comes to early June? You're going to be behind. You're going to have a car that's in the 15th iteration. You got 5 more iterations to go, you even realize it. Okay? Okay, well, the more people you have on a team, this is why I was flabbergasted with 346 members on the team. If you got 2 of us, Steve and I talking to each other, it's 2 lines of communication if we're cutting both ways. There's a simple relationship up there, and I can share this slide with you guys later if you ever want, but it goes up with the square of number of people. So if we just had 15 people, we got 210 two-way communications we have to do. Okay? If it keeps going up, you have 346. I can't count that high. I can't do that math. I didn't go to a good enough school to do that. But it's very large. Thousands, I mean, hundreds of thousands, actually, in that case, probably over 1 million communication channels. Stabilizing it the way they did is a way to manage that. You can't have everybody talking to everybody. It's very difficult. So tiering it the way they do is project-based while still being within their individual subsets is important. Okay, we'll go past that. It's difficult to be concurrent, and we're trying to get to finals here. So go back one more slide, if you will. Back one. This is one thing I do want to address. A lot of cars that we've seen in the last few years have been very low complexity cars, okay, which is more of an incremental development. We're starting to see a little bit more, which we're happy to see, what will be a real higher complexity, more complicated type application, which is more of a seminal development type work. As a student, it's very difficult to do clean sheet designs, okay? And many times you'll fail trying to do that. Now, failure is a way of learning, of course, but when you've got a whole team of 20 or 30 or 300 students, you can't just be repeatedly failing or you'll lose interest among the other students on your team. So you have to manage the amount of failure you have, if you can imagine that. You got to reach a little beyond what you can grasp or imagine, but don't go so far that you're not going to be able to complete the task. What I recommend is if you've got freshmen or sophomores on the team that you think aren't quite ready for prime time for all their knowledge yet, if they've got a pet project that they can help with, it might not go on this year's car, but it might be good for the following year's car, or even the year after that. So they could work on a 1.5 or 2 year program for that. Okay? Go ahead. Okay. So we're going to go into awards. I think we got some here, right? Yeah.
Here's your listing.
Okay, we got them right here. We have all of the judges reviewed all the 3-view drawings, and we took we decided to take the top 10 teams. So we have up here, we're not going to ask you to come up right this second. Well, could we? You want to do that? Want to pick them up? Okay. Go ahead and hit a few more times here. Okay. Each of these teams, you see your name up here? Come on up. Bring 1 or 2 representatives. We'll give you your poster, which is your 3-view drawing. It's a nice banner. Back up one. Okay. So these teams have all been 4th through 10th. Okay. So, FEI, come on up. UTA. A lot of people, while they're collecting this, I want to say, a lot of people wonder why the 3-view drawing is even used. We got CAD programs now, we're doing all the simulation work. When you go out into industry and you want to have various items machined, you may find a lot of machine shops still need a 3-view drawing to get it done right, okay? And so being able to do that and trying to explain your design to somebody is often difficult just being in the computer, particularly if the person doesn't have the software and so forth to look at. So it's very important still to have this capability.
Here we go. Third. Hit it once. Okay.
Third place, Kennesaw State. Are you here? Thank you, Kennesaw. We also got to see your car before we started judging on Wednesday. You donated the car for us to do a little of our training for our judges, so thank you. Okay, second place, University of Florida. You already picked it up before your incident earlier. No, honestly, that was a serious thing. I don't know if any reps of Florida are still here, but our hearts are out to them. Hope no one got injured or issues there. So, but they did a phenomenal job. Okay, we'll mail them the ribbon of second place. Okay, next one up for first place in a 3-view drawing, Michigan Ann Arbor. Okay, this year, we originally thought when we had only 60 cars to look at, we usually try to take around the top 10, 8%, 10%. We're thinking we're going to see 5 or 6 cars. It turned out we had really difficulty excluding anyone below or above 9th place. So we brought 9 cars into finals, which was a high number for our EV competition. But I think all the teams that were there deserve to be there. And I want to give a mention to the teams that finished in 10th through 4th. So 9th through 4th. 9th was a National University of Singapore. It's not easy to get here nowadays with a lot of the travel issues we've had. And they did a really good job of making it here in the finals. So good job. All right, 8th place, we had Carnegie Mellon University. Okay, 7th place, RIT. In 6th place, oh, I'm sorry, there was no 6th place. So we had a tie. These two teams, we went down to the last vote on the judges, back and forth, and it had to be a tie. We really very rarely have a tie in the top 10, so or top in finals. So Georgia Tech and Washington, great job. EPM from Montreal. Okay, you hit it once, please. All right, now we've got, we're done, right? Is there nothing more to do, right? Okay, well, maybe we'll try one more here. We had 3 more teams. First place, we had 35 of our judges were in finals last night, and over almost a third of those, the first place team got scores for that. In second place, 20% of our first place scores went to the second place team. And they were very, very close in a lot of other areas with regard to our second, third, fourth placings. But third place score was for 140 points out of the total 150. So you can see we're pretty tight here, first and second. It could have gone either way, but it was a pretty good competition. You can hit that once, please. Okay, second place was Ecole de Technologie Supérieure. Come on up and get your trophy.
Everybody, come on up. Come on.
Good job. Great job, PTS. Within 3 points of the win. Okay, Michigan Ann Arbor is our third place team, 140 points. Come on up. Okay, I think one of the teams here knows who they are. Our champion for design judging for 2023, drum roll please, for McGill University. Can the stage hold 300 people? Cool. Okay. Thank you. Congratulations. Okay. Okay, that concludes the portion for design. Kaylee and the welcoming or closing ceremonies staff, where may they be? Okay, you guys get a break.
All right, so the top 3 cars in design are parked right outside the tent. I would urge everybody to go have a look at them. They are sterling examples of design for 2023 Formula SAE EV.
Okay. Again, thank you for coming. All of you participants, being able to make it out here was quite the task. So, but we're expecting even better next year.
Thank you all for attending.
okay. I'm used to being through a compressor. It takes a lot to take the edge off. How y'all doing? Good. We're going to get started early. I'm going to go real fast. I know you're all expecting me to put on hats and glasses and stuff like that, but we got to move because I know you want to go home. So here we go. Fire bottle 1. Anybody? No. Fire bottle 2. No. Okay, stuff with names on it. This is easier. Florida. Is Florida here? Florida, are you here? Okay, no. Ann Arbor. U of M Ann Arbor. This is your stuff. This thing says 160 on it. Black notebook, 160. Course notes. Yeah? Okay, no, you're snapping at a friend. Okay. Thanks. This one has thermal transfer notes, which then heat transfer notes, which then become an SAE notebook. I guess you dropped the class. Okay. Hey, heat transfer's hard. Okay. Trader Bay jacket. Gray jacket. This guy? Yes? No? Maybe? Gone. Blue jacket. Again, maybe same person lost 2 jackets in one weekend about the same size. Ready? Gone. No. PPE. I know some of you need this. Is this your PPE? Yes? Maybe? Yes? Is this yours? Sure. Take it. Socks. I'm not pulling the socks out. It's in a speed glass bag. Socks. They're here. Arm restraints. I think these are the ones that are the supposedly good ones. Arm restraints. Simpson's arm restraints. They're in the bag. 9.5 G-force black boots. The low-cut ones. The ones that have the kind of funny base to them. Okay. Someone's Camelback bottle. Okay. Someone's, POWE. No. Other gloves, I just dropped one. Race Quip gloves, no gauntlets. This is Larry's hat. I swear I didn't plant that. Someone's radio. I'm not going to talk into the radio. I think it's dead. Okay. A lot of random gloves. Please come get your random gloves. Your extremely stinky balaclava. I'm not wearing this either. The arm restraints that I was told to tell you are not the types of arm restraints to have. We don't like them because they can trap you in the car and the Velcro sucks. Don't use these. Are these yours? No? Good. Don't use these. A lens cap, a projector lens cap found in a business center after presentations. No. Extension cord. No. Stanley knife, literal Stanley knife. No. Wide Ray-Bans. I know what you're doing here, people. I'll leave those there. Earbuds, earpods. There's another, okay, I think that's the only set in there. Great. All right, one more box. So many clothes. You know what? We're just going to say so many clothes. If you're still missing clothes, please come get clothes after the competition. There's also 2 backpacks here. One's a Skidoo, Ogio, one's a Swiss Gear. If you can identify the stuff inside, it's yours. Please stop leaving your stuff at competition site. We don't want to take it home. It has to go to my house, and I don't have any more space. I have too many motorcycles and too much junk. Help me out, okay? Okay. We're just going to put all the clothing away for now. Anything else in there looks mission critical? No ID? No nothing? Great. You all want to go home? So do I. Ready to do this thing? All right. Are streaming folks ready to do this thing? Okay. Great. Well, as the Formula SAE 2023 season ends, SAE wants to recognize all of you for your hard work and your dedication as you put into designing and building your vehicles. It's a tough challenge, and we're happy you made it here this week, and we're happy you're here with us learning this week. It's your efforts and your passion that keep Formula SAE going, and it's what makes it a challenging and valuable competition and makes it worth coming to year and year and year again. And hopefully you've learned a lot, and you're going to take this knowledge and bring it into your exciting careers. We want to thank our volunteers. It takes a lot of people to put these events on. So on site, we have over 300 people here helping to run dynamics, logistics, judging, everything all over the place. So we want to thank everyone who volunteered, and we want to thank the dedicated teams of volunteers who reviewed all of that documentation that you sent in. So let's give them a big round of applause. Special thanks to the folks reviewing the safety documents. We also want to thank our sponsors. Without the sponsors, without their monetary and people resources, these competitions would not be what they are today. So I'm going to list these alphabetically, but these sponsors all help make this event possible. We have Actilent, Altair, American Honda, Analog Devices. We have Ansys and Autodesk, Blue Origin, Bosch, Cummins, Daimler, DS SolidWorks, E-Controls, FEV, the Ford Motor Company, Gauged Engineering, Garrett, GM, Hermes, HF Sinclair, Hoosier, Magna, Mala, MathWorks, Multimagic, NCES, Nissan, Packard, Polaris, Relativity Space, Rivian, Roush, Siemens, SpaceX, Stellantis, Tesla, and ZF. So let's give them a big round of applause. Hopefully you got to speak to them this week as they were here on site. We really appreciate them being here. Okay, time to give some stuff out, but not your own stuff back to you. So our first award will be presented by someone who's been with the Formula SAE program for a very long time, who was integral in the design of rules and regulations. The Learn and Compete Awards are an award given out to teams for copies of a 2-volume set of books on learning and developing Formula SAE cars and programs. And here to present those books is Mr. Michael Royce.
Okay, I choose these recipients based upon teams deserving of some assistance in their efforts to improve their performance at the competition. And you need to be here to pick them up, because it costs me too much to mail the dash things, as I've already paid for them. Okay, so we start with Missouri Science and Technology. Are you here? No. UC Davis. Drexel. Anybody from Drexel? Northwestern. University of Victoria. Nope. Moving up, UC Santa Barbara. Missing out on $80 worth of books. UC Riverside. We're back to where we were in May then, Alton, by the look of it. Louisiana State. Looks like I'm going to be taking a bunch home. University of Cincinnati. Cincinnati. Well done, okay. Read well. UC Berkeley. California teams don't like Michigan. University of North Carolina, Charlotte. Berkeley. Hey! UNC Charlotte. Anybody from UNC Charlotte? MIT. Anybody from MIT? Hey! Well done. Thank you kindly. RPI, Rensselaer. Rensselaer. San Diego State. Rutgers. Missouri. Dalhousie. They got a long way to go. Dalhousie. Well done.
Thank you. Appreciate it.
Okay. And Centro Universitario da FEI. I believe they're what, Brazilian? From Brazil? They're not here. Concordia.
Hello? Oh, I'm good. I'm live. Okay. Thank you, Michael. Good luck. Enjoy those books. They're excellent resources. I've been asked to call out two schools. One of, I don't believe, is here. The University of Missouri Columbia. Do you have a representative here? If you're watching the live stream, you should know that you still have your transponder and SAE wants it back, and you owe them $1,000. Get your transponders in. UBC, are you here, British Columbia? UBC? UBC and a check in the mail, or a bill in the mail, rather. Okay. Up next, an award that I think is important for a lot of us who have been doing this competition a long time. The Carol Smith Faculty Advisor Award is going to be presented by Peter Jones and Dale Frame, our divisional representative from the SCCA.
Good evening. I must confess that as an SCCA administrator, I'm not used to looking at crowds that are so young. Most of us are old and gray and look like me. My name is Dale Frame, and I'm here representing the SCCA Board of Directors today, the Sports Car Club of America, for those of you who don't know. I was elected Area 4 Director, which is Michigan, Indiana, Ohio, Kentucky, and West Virginia a couple of years ago. I've had the distinct pleasure of doing things like this quite a bit, and this is really, really cool for me to reach out to the folks that are doing EVs. I'm an EV guy. I'm on my second one. I love them. Awesome. This is the Carol Smith Mentor Award, and Carol Smith was a legend in designing and engineering race cars back in the 60s and 70s. And he was a longtime member of the SCCA. He designed cars that won Le Mans a few times in a row back in the late 60s. He's just a legendary figure. And for guys like me who raced starting 20 some odd years ago, his books that he wrote in the 60s and 70s, Prepare to Win, Tune to Win, Engineer to Win, etc., they're still must-reads. So if you want to go into that field, those are the books to get. So this cup, excuse me, this cup recognizes the faculty advisor's role for an outstanding contributions to a competition team. All you kids know what your advisors bring to the table, right? Specifically, the information they're looking for is a continuity, creating a positive and encouraging environment, actively involved in all of the team challenges that are technical and organizational, etc. And just real quickly, I'll read off some of the teams that that are here that won this award in the past. Texas Arlington, Cornell, Georgia Tech, Rochester Institute of Technology, Texas A&M, Auburn, Oregon State, New Mexico, Maryland, Cincinnati, and Texas Austin. And as a guy who grew up in Oklahoma, it pains me to see 3 teams from Texas in here. Yeah. We'll have a discussion in the parking lot. I kid. Anyway, so the nomination forms were sent out, and some of the quotes for this year's winner: rare ability to inspire, motivate, and bring out the best in the team, prioritize the success of the students, boot camp in casual, comfortable setting. I'm not sure if I know what the hell that means, but okay. Allowed the team to concentrate on building the best race car possible. That goes without saying. The advisors do the heavy lifting and herding all the cats, right? So without any ado, this goes to Dr. Saya Kar Heng from the National University of Singapore. Along with a check for $1,500, which will pay for about 1/3 of a plane ticket back, right? Something like that. Is anybody here from that team? Figures. The first time I do this, and what happens? All right. Well, thanks very much, folks. I appreciate the time. SCCA and the FSAE have had a long-term relationship, and this is a very proud moment for me to carry this mantle and move it forward. Thanks very much for your time.
All right, our next award is presented by General Motors. If you've seen, we have a lot of General Motors volunteers. They've been wearing their really cool hats. Here to present GM's Everybody In Award is SAE Relationship Manager at General Motors, Andy Jeffers. Come on up, Andy.
Thank you, everybody. I guess, I have kind of a weird title, SAE Relationship Manager, but what that really gets down to is I've had a lot of activity with SAE in the past 35 years. I've been with GM 36 total years, soon to be heading down the highway, retiring. So I think that's why they asked me to come up here and do the award, is if I screw it up, they don't have to worry about asking me back next year. But the couple things I wanted to talk about today before we get to the award is the importance of the SAE membership. Y'all have seen probably one of the best parts of SAE, and that's the Collegiate Design Series. And, please think about taking that membership from when you're in college, taking it into industry. There's so many different things you can do with it, and it really enhances your technical knowledge, it enhances your relationships, your network. It has made a huge difference in my career and my technical abilities. So please keep up the memberships and put it to use. Second thing is the SAE Foundation. The SAE Foundation is kind of the charitable side of SAE International. It is also the reason you guys are here. It's through the donations of individuals and corporations that really allow us to go in, make this a competition for global teams to come here. So as you go on, if you have a chance, when you go to do your membership, check that box and make a small donation. Keep it going. It's one of the ways that if you're not going to be active and come out and help and volunteer, please help pay it back for what you all have gotten out of this. The other one is a World in Motion. STEM education is huge to get kids here. World in Motion gets you into the classrooms, and I know a lot of these teams have some presence in the classrooms, but it's a K through 12 opportunity to get into the classrooms, start kids down the path for STEM education. You all had somebody in your in your background that helped you get towards where you wanted to go into engineering. A lot of kids don't have that. So please mentor, please help out, and look at going into a world in motion. The last thing I want to hit is GM participation. It's really part of our culture to be volunteers within our community and volunteers within STEM. We had over 130 volunteers here this week. So of that 300, we had over a third of them. And that's really comes from the top levels of our company to ask and cajole and recommend that we come out here and be part of this, because you get a lot of energy from working with all you to see what's going on, to see new things out there, and to try to get great employees coming to us. I just wanted to mention we've got 3 really integral people to this from GM: Mark Scott and Adam Niner. They'll be throwing some hats out to you as we go. Jackie Zimney, who is right here. Jackie has been... It's our version of the T-shirt cannon. Jackie has been awesome the past 2 competitions on trying to do recruiting for us. This is really important to have the relationships here. The last person I want to recognize is Alba. Alba may be with Hendrick, but she's still part of the GM family. And talk about volunteering. I don't know how many people that she has been integral in hiring and getting to work. Thank you. So thank you, Alba. So the real so what of it is get involved, stay involved, and make your membership really work for you. So just like each one of you, General Motors knows the time you spend in engineering a race car with your team is immensely valuable. We've been there. We know what it takes. We know what kind of experience go into building a multidisciplinary team, overcoming design challenges, and coming together complete in a world-class environment. We want to recognize what you and your team are doing to engineer the future. The Everybody In Award grew out of our desire to make a meaningful connection with students and teams while also sharing in the values of our Everybody In campaign: safety, electrification, and social impact through inclusion. Embodying the spirit of Everybody In goes beyond just building a race car team. We envision that the team who receives the Everybody In Award demonstrates the following core behaviors: a pervasive safety culture, a commitment to reducing emissions by seeking out opportunities for efficiencies everywhere, and a persistent good faith efforts to be inclusive of everybody in and around your Formula SAE community. This competition's winning team demonstrated their entire team's commitment to the pillars of Everybody In. This team embodies the safety culture in everything that they do. The team prohibits high voltage work and machining during late night and early morning hours to ensure that they're, is that a good idea? To ensure that the team members aren't doing dangerous work while exhausted. They instituted minimum standards and guidelines for working hours, including providing proof of sleep, taking multiple breaks, and eating meals. I don't think sleeping in class counted towards that, but you can always work towards that. Further, the team developed their own accident and injury reporting process, which involves and goes beyond their campus's EH&S reporting process to ensure that the hazards present in any accident can be mitigated in the future. The team is also dedicated to zero emissions future and has been competing in the EV class for several years. They continue to challenge themselves by seeking out even small opportunities for improving efficiency of their car and of their team, such as switching to new battery cells and motors and improving accessibility for serviceable components. And finally, this team's commitment to inclusion is plain to see. A majority of their primary leaders are BIPOC. They partner with numerous organizations across campus to engage and attract a diverse base of students. The team is also active in their community, volunteering with SAE's World in Motion to bring STEM and K through 12 students, hosting charity fundraisers for causes they are passionate about, and conducting STEM enrichment talks in local schools. It is my pleasure to announce that the winner of the Everybody In Award is the University of Texas, Austin. That's it?
Thank you, Andy, and thank you, GM, and congratulations. Up next with the Cummins Innovation Award is Austin Perry. Austin is an NC State FSA alum, and he's a test integration engineer at Cummins, up here to present their 3 Cummins Innovation Awards.
All right, good evening, everybody. My name is Austin Perry, and I'm with Cummins. First off, I just want to say congratulations to all the teams just for making here to competition. It's a major accomplishment just to get a car here. Cummins is really proud to support FSAE. We think some of the brightest engineers are right here in this room, and we love being able to come out here and interact with you guys every year. The Cummins Innovation Award recognizes innovative student work, both in powertrain and all other parts of the vehicle. This year's prompt focused on cost-effective engineering solutions and necessary changes that were made during the validation process while you were building your vehicles this year. We have 3 awards to give away this evening, and I'm going to start with third place. Third place award is made from a piston from an ISB 6.7 liter engine, and it comes with $500. This team showed an innovative approach to a design issue with their pedal box using 3D printing with chopped reinforced carbon printed out of nylon, and their innovative brake system optimization software. In third place, Rensselaer Polytechnic Institute. Anybody from Rensselaer in the house? No. Okay. In second place, $750 and a trophy made from an ISX 15-liter piston. This team showed their problem-solving process for their motor cooling circuit and innovative thinking related to cutting costs around mold materials. In second place, University of Washington. And finally, in first place, $1,000 and a piston out of our 95-liter engine. This team showed innovation in troubleshooting driveline angle-related failures by integrating their differential carriers into the rear crash structure and developed a cost-effective slip angle sensor using off-the-shelf GPS receivers. In first place, San Jose State University.
All right. Congratulations to all the winners. Innovation awards abound here at Formula SAE Electric. Our friends at Garrett are also presenting the Garrett Powertrain Innovation Award. Here to present that is a fuel systems engineer from Garrett, Yara Nejdi. Hi, Yara.
Hello. So Garrett is very proud to present our first annual SAE International Powertrain Innovation Award. So Garrett is a worldwide technology company that continues to sponsor and support innovative technology. We want to thank all the universities that applied. Sorry, that was a long walk for me. So we want to thank all the universities that applied for their differentiated designs. Everything was really great. We got to see a lot of great technologies. And the recipient of this year's award that we were able to judge, and it comes with a $3,500 award, is Carnegie Mellon University. So the award for Carnegie Mellon, congratulations, is for their battery management system, going from dual off-the-shelf boards to their own single board design. And they found solutions beyond what was available to them. So congratulations.
Thank you so much, Garrett. Thank you, Cummins. Thank you, GM. Thank you, everyone. One more big round of applause for our sponsors and all those specialty awards. All right. So now it's time for some of the hardware up here. Before I begin, I will say this every time. Please do not jump on the stage. The stage has had a long week like all of us. We're going to start with the Business Presentation Award. Teams presented a business case for changing the power system in their vehicle. They presented in preliminary rounds, and then teams presented here on site in finals. From those finals, the judges have selected 3 teams to receive the top 3 awards. So, in third place in presentation, we have Kennesaw State University. There's a lot of them. Please no jumping. All right, congratulations. In second place, a team who did a great job and I know is not going to jump on the stage, the University of Washington. Thank you. Well done. But one team gets to take home the first place prize. And that team is Toronto Metropolitan University. Congratulations. Awesome. Now, I know that a lot of us don't love thinking about costs when we're building fun race cars, but the cost event is an important part of the educational experience here at Formula SAE. Teams prepared reports and then defended analyses of scenarios in the cost event. Combining both of those scores together, the judges decided that 3 teams clearly provided the best responses. And so, third place in cost is Toronto Metropolitan University. Congratulations. Congratulations. In second place in cost, a team that also did a great job with their case analysis and also with a great report, building a vehicle that hit a great cost target. Second place in cost goes to Cal Poly San Luis Obispo. Congratulations. Thank you for the money. Do you want your like $11 back? Oh no, wait, it's actually like $25. I could use this for the Lemons car. Yo, lemons ain't cheap. All right, all right. My God, how did you win cost? Okay. But one team again, someone has to be the best, and when it came to both the cost of the overall vehicle and their analysis in the scenario, the team that rose to the top in the cost event is Kennesaw State University. Thank you for not shoving money in the cup. Congratulations. Now, the design judges passed out the last of our static awards, so we're going to move on to the dynamic events. Remember that this event is both an evaluation of your engineering knowledge and an evaluation of the machine that you built and validated and improved and brought to competition. And so the events that you did yesterday, acceleration, skid pad, and autocross, prepared you for today's event. In the acceleration event, teams are asked to accelerate as quickly as possible to demonstrate the performance of their vehicle. And so this isn't a judged event, it's them against the clock. And in third place in acceleration, we have the University of Washington. They were pretty fast. Now, you may have noticed that, that Stellantis is sponsoring our acceleration event. They did a really cool warm-up for us, and they did a great job getting their car down the track. Another team that did a great job getting their car down the track very quickly is our second place finisher, ETS. I'll get you your bag. I should note that the award doesn't always come with someone's backpack. Many were fast, but one was fastest. So if you watch the acceleration runs, this vehicle was seriously impressive. Your overall winner in the acceleration event sponsored by Stellantis, Georgia Tech. Congratulations. Well done. Congratulations. Congratulations. Now, longitudinal acceleration is important, but so is lateral acceleration. And so teams also demonstrated that their vehicle's cornering prowess was as good as its acceleration in the skid pad event. In the skid pad event, 3 teams rose to the top. In third place in skid pad, we have Carnegie Mellon University. Congratulations. Second place in skid pad, I know you've read the results. Second place in skid pad is another team that did an excellent job developing a vehicle that did a really good job in lateral acceleration. That team is ETS. There's no more backpacks, sorry. Good job. I almost lost my place, but I'm sure they know what's coming. Your overall winner in the skid pad event, faster than anyone else, more G's, is Georgia Tech. I guess I get the trophy. Oh, you get the trophy? Okay. Well, hold on, let me down. I'm not part of the team. Now, if you had a chance to watch the action yesterday afternoon, you would know that the highlight of the day was the autocross event sponsored by Magna. And if you paid attention to the run order today, you already know what I'm going to say, but I'm going to say it anyway because we want to congratulate them for their times. Third place in autocross, sponsored by Magna, is the University of Washington. Congratulations. As they're getting settled in, again, autocross was very competitive. Our second place finisher did a great job, great car. That team is High Tech Racing, Georgia Tech. Oh, there's my pen. However, one team rose above them all, and in winning autocross also got that coveted final starting spot in endurance. So your autocross winner, sponsored by Magna, ETS. Congratulations. All of these events, though, were lead-ups to the big one. So today, 23 cars attempted the endurance run. The endurance event, sponsored by Ford, is the pinnacle of our week here. It's a 22-kilometer test of endurance, of vehicle reliability, of vehicle performance, and of strategy. Third place in endurance goes to Carnegie Mellon University. Congratulations. Thank you.
We're going to need a bigger stage.
Awesome. Congratulations, Carnegie Mellon. Second place in endurance is another car that looked very impressive, it performed impressively, and it went the distance and did so in a very good time. Your second place finisher in the endurance event is the University of Washington. Congratulations, Washington. only one team can be your overall winner in the endurance event. You got to go fast. You have to make very few mistakes. You have to do it right. It's a demonstration of your vehicle's prowess. And the overall winner in the endurance event, sponsored by the Ford Motor Company, is Ecole Technology Superior, ETS. Great job. Now, as I'm sure all the students know, but maybe those of you watching at home don't know, the endurance event has within it a second component. We fit the vehicles with an energy monitor that evaluates how much of their battery capacity it uses during this run. And vehicles are evaluated on how efficiently they complete that 22-kilometer run. Now, Ford also sponsors the efficiency event because just like going fast and going far on a charge is an important part of building an effective vehicle. And so, third place in battery efficiency for Formula SAE Electric 2023 goes to the University of Minnesota Twin Cities. Oh, pickles. Thank you very much. Enjoy the pickles. Our second place finisher in battery efficiency completed that 22 kilometers using less energy than most of the rest of the field. Our second place finisher in efficiency is the University of British Columbia, UBC. Okay. SAE will mail them their trophy. And I get to stay up here and congratulate the overall winner in battery efficiency, completing the event using less energy than any other team. The car was fast, but it was also efficient. Your overall winner in efficiency, presented by Ford, the University of Texas, Arlington. Congratulations, great job. All right. Awesome job, everyone. Now, before we start with the overall awards, the Spirit of Excellence overalls, I just want to give you a couple of final reminders and a couple of requests as we wrap up our event here. The first and most important one is, well, I say the most important. I'll say it a couple of times. We want you to get home safely. Take the time to pack your trailers well, get things set up right, get some rest, get home safe. We want to see you here again. As you're leaving this building, please fold up your chairs and stack them in the back on the racks. Helps us get the site broken down faster. The volunteers really appreciate that. And clean out your paddocks. Please take your stuff home with you. Don't leave us chairs and awnings, stuff that we can't dispose of. Please take your stuff with you. Put your trash in your bags, tie your bags up, and put your bags at the end of the paddock. We appreciate you helping us out with being good stewards of Michigan Speedway. We appreciate them having us here. They put on a good show for us, and we want to repay the favor. So, the Formula SAE Spirit of Excellence Overall Award is sponsored by SAE International, and we award trophies to finishers in the top 10 overall positions. We'll start from 10th place. These teams scored points in lots of categories. They did well, combining excellence in a variety of disciplines. Our 10th place finisher overall is Georgia Tech.
I'm wearing my glasses.
Okay. In 9th place, overall, again, a team that scored points in lots of different categories. And they did a great job here at competition. It was great to see them out here. Our 9th place finisher is the University of Texas at Arlington. All right. Counting down from 10, we have our 8th place finisher, a team that, I remember racing against them when I competed, and it's great to see them at every event, and we love to see them out here. Our 8th place overall finisher is Virginia Tech. Congratulations. In 7th place, a team that combines strong finishes in several categories with consistent performance across the board, the University of Minnesota Twin Cities. I will admit I don't understand the pickle thing, but I'm glad you're having fun. Is everyone having fun? Did you all have a good time this week? Good. Mandatory fun. Okay. Again, another team that put together strong performances in a lot of categories. They did a great job. We love to see them out here competing like we love to see all of you out here competing. Your 6th place overall finisher is Kennesaw State University. All right. I definitely did not lose my place on the sheet. It's funny, I complain about having to wear the other glasses and I still can't see. Okay. There we are, 5th place. So, 5th place overall. Points go up, performance goes up. Another great finisher, another team we love to see out here at Formula SAE Michigan. In 5th place overall, the University of Toronto. Congratulations to them. And while they're going back, another brief announcement. If you need a box for your award, SAE has them available. They're happy to give you one so you can pack up your stuff and take it home safely. Okay? Also, if you're looking for the official results, please watch the app. There'll be an announcement next week with the official finalized scores. Now, in 4th place overall, Rochester Institute of Technology. Congratulations. Congratulations. And now we get to the really big hardware. You'll probably want the box for these ones. So I have to ask, because I've left them here taunting. I can see the trophies better with these. But I appreciate that you left me glasses. I'll cherish them forever. Okay. In 3rd place overall, winning this big, lovely trophy, which will probably ballast your trailer down, oh my goodness. They did well in a lot of categories. They've been up here a few times this evening. They built a great car and they performed very well. Your 3rd place finisher overall is the University of Washington. before I present the second place award, any special announcements, anything extra? I have the one last one that I'll do in a second. Yes. If you have not registered for the EV workshop and you are interested, we encourage you, register for that workshop. It's a great way to learn about these vehicles, learn about the technology, make your vehicle better. It's a great program. So look out for that. In second place overall, another team you've seen up here a few times this evening. Oh my goodness. I'm going to break these things. Got to do curls with this. In second place overall, winning a very lovely trophy, Carnegie Mellon University. Who gets the cup? Nice job, everyone. You got it? So, before we present the overall winner, I want to just make a note of something, because Formula SAE is a big family, and it takes a lot of folks to make these events run. And there's a pair of folks who I care about very much who are retiring this year after 30 years supporting this event. They've been here at MIS. They were here at the years we were at the Ford Romeo Proving Grounds. They were here for the Silverdome years. They have been a part of the SAE family, and they've made this event run in ways that you may not notice, but it's a big, complicated machine. You may know him as Santa. I do too. But Rick Maynard is he's a person who means a lot to a lot of us who put this event on. And we're saying farewell for now. And Rick, come on up and I want you to say hello to the students, and hopefully they can say hello to you. You've done so much for all of us. You may not know this.
Okay, it's really simple. Santa and Mrs. Claus are signing off, and we'll be going to the North Pole. Goodbye.
I'm going to go off script for a second. Sorry, Kaylee. 30 more seconds. So you may notice that a lot of the folks who are here wearing volunteer badges, event organizer badges, they're folks who talk about when they were racing. We come back and we work this event because we care about it. We care about the educational opportunities. We care about the experience. We care about the fun. And we care about helping you learn. So if you are considering coming back and working the event, I cannot encourage you enough. It's a lot more fun on this side of the tables. Okay, so if you're graduating, FSAE Online, if you scroll down, you can become a volunteer. I encourage you all to do it. It's a good time. Last thing, now I'm back on script. We really do look forward to seeing you next year, which means probably another event here, maybe not, we'll see, but another Formula SAE electric event in June. And we want to see you all back here, which means we want you all to get home safe. So take your time, make good choices as you're driving, and we will see you all in 2024. Sound good? All right. Take everything you've learned and make your cars better. Your overall winner for Formula SAE Electric June 2023 is ETS. Congratulations. That's all I've got. Thank you all very much for joining us. We will see you all in 2024. Get home safe and get some sleep.